Where is the cosine's derivative coming from? Let's do it here real quick. So we can expand the derivative by the standard definition, which is the limit when the x, which is really small, tending to be 0, right? Divide the difference between these two angles, right? The cosines x plus this really small angle minus the cosine x. So this rate will basically define what is the derivative. So how can we do this? We first have to recall the trigonometric identity from the addition of two angles. We have the multiplication of each cosine per angle minus the multiplication of each sine of each of the angles, right? After that, we can substitute inside of the limit. But if you see here, we have this cosine x here, cosine x here, that they doesn't have anything to do with the limit. They can go outside, so we can factorize these two, right? We will have this minus 1 because here we cannot remove it, and all these this part can go outside as a second limit. Remember, we have a theorem that the addition of limit, or the addition inside of the limit, can be distributed inside with a limit for each term. That is exactly what we are doing here. So in this part we have the cosine x multiplying by wherever is still keeping the h, minus, because we have this minus here, the same thing, the sine x multiplying by the sine x h divided by h. But these limits, we can put this outside, and these will be standard limits as we do here. So we have minus cosine. This minus, where is coming from? If we take minus 1 from here, we change the sign internally, and we basically put it in this form, 1 minus this. So we have this minus outside. This minus is coming from here. And this limit is a standard limit. We can use the squeeze theorem to obtain this. Same thing for this one. So this will tends to be 0, tends to be 1, and that it is. If this is 0, basically the multiplication of this minus cosine x by 0 is 0, minus x, and this is 1 multiplying by 1. So therefore the derivative of the cosine of x is minus sine of x.